get started. Hi everyone, I hope you can hear me. I am doing a series of little Twitch streams for learning how to do Babylon.js, but I wanted to talk about how to create basic 3D scenes first. So if you want to follow along, the lessons short link I am adding to the stream, which is bit.ly WebXR curriculum. And in this curriculum, I will talk about the basic stuff and then work on some projects too. So skipping through the concepts now, let's talk about creating a 3D scene. Basically, to create a 3D scene with any of the libraries, there are three things that you need. One of them is a scene. You can think of your scene as your stage, where you will put everything, every object, actor, and then you need to light your scene so we can see something, and you also need a camera. So that will be our point of view that we will render from. Basically, scene is an object, so you add the camera and lights and the 3D objects to the scene. And of course, we need an object to display, and which is going to be a box. We call every shape a mesh, which means that this is the total of our material and the shape itself. So let's start with BabylonJS example. First, we have to, this is the code example, to create a scene on the playground. This is playground specific because that's the easier way to get started. So I will show how to run this thing in your local later on. First thing that you need to do is to create a scene object. We are initializing the scene object by giving it the engine. But if you were doing this on the playground, which is the link below here, the engine is given to you, so you don't actually have to worry about it, but you still have to pass it to the scene object. Next thing we need to create is the camera. So let's see what it looks like actually. This is the this is running inside our playground. You can see the code and change it there too. And second thing that we have is a camera, and this is specifically an arc rotate camera. What it means is that this arc rotate camera orbits around the targets that you given. So no matter where you move the camera, if it's targeting to the center of your scene, it will always target towards your scene. So it won't change its focus target area. The values that we are passing in, the parameters are, first thing is the name. This could be any string. This is for you. You can leave it empty as well. And the second thing is the alpha radians with the longitudinal, I can't say this. Well, you can read it. We are passing in alpha, beta, and a radius. So you could see the alpha rotation and the beta rotation, and radius defines how far away from this the camera is, from the target object the camera is. You can think of this as moon and earth, maybe. Earth is in the center, moon is the camera, and you're going around. So you define in what angle you go around, basically. One word of caution here, setting the beta to 0 or pi causes a problem. So you have to have some value. It could be 0, 0, 1, but it has to be. Finally, the last thing that we have is the hemispheric light. This is to simulate almost like an ambient environment light, which means kind of like a candle light or some natural light source like that. It's not a spotlight, basically. So in this case, we are doing the bare minimum, which is giving it a name and set its location. So if you look at the code, the location of it is a vector, Babylon.js vector tree, which means that it's defining x, y, and z values. So it is coming from up top. So you can change any of the values here on the playground, and if you press play, you will see the changes. Let's see what happens if I put the light in the center. So it is in the center, and our cube is in the center too. So it's not doing a very good job of illuminating it, but it looks kind of cool. Okay. And box mesh itself. So we have this helper function, which is mesh builder. If you scroll over it, you can see the definition. Class containing static function to help procedural build meshes. Okay. And then we have the create box method of it that we are calling. We know that this is a method because it has parentheses. And if you scroll over that too, you can see the parameters that you have to give. Anything that has a question mark next to it means that it is a optional parameter, so you can skip it. In this case, we are actually skipping all of it, right? We are giving an empty object. So we can define the size, width, height, depth, or just leave those empty. Face UVs I'm not going to get into, but it has something to do with putting textures on it, so we'll cover that later. And updatable is a boolean. Well, I didn't know this existed. I'm guessing that if you want to have a totally static object that never moves, you are defining it, and there's probably some performance adjustments according to that. If you are not going to move something, you will never check it over and over. Finally, the last thing that we give is the scene, also optional. If it's not given, it knows that there's one scene in here in this playground. So that is pretty much it. And if you come and try to do something, drag the box, nothing actually happens. To fix that, we have a camera controller attachment. You can uncheck the line 5, uncomment line 5, and run it. Now, if I come over it and click and drag, now I can move it as much as I want, which is awesome. And you can save this example, and if you want, you can use the inspector. You can see what is in there. There's a box, there's a camera, there's a light. Woohoo! Material, default material, that's why it's gray. There's no texture, no rendering pipelines, this and that. All right. And, ooh, this is nice. So we have a count of the meshes, which means that you can actually see if your model, in this case we have a very simple box, has a lot of meshes, which means that it is very heavy to render. So you can do something about that. Oh, we can take a screenshot, record a video, capture. This is really awesome. Create a GIF. Oh, so let's start doing that. And stop. And it created and downloaded a GIF for me. Let's see. I guess I need to open this on a browser or something. Maybe if I just drag it. No, it didn't. Okay. Figure that out later. Cool. What else we have? Okay, not gonna get into that. This is BabylonJS, and if we look at the Three.js example of the same exact thing, it's very similar, but it has some syntax differences. Again, we are creating a scene, and we have a camera, perspective camera, which is almost a default camera. And let me try to remember what the parameters were. So the last two is the near and far clipping points, which means that anything that's closer to the camera, closer than 0.1, will not be rendered. Anything further than 1,000 units to the camera will not be rendered. This is the aspect ratio. This means that the camera is going to capture in the same aspect ratio of your canvas. This is good. So we always, you can do windows inner width divided by inner height. You could do half of it or like multiply this value, but it has to be the same ratio as your canvas, basically. I think the first value is the focal point, which is has to do with your camera lenses. I'm not going to be able to explain that now. One other thing that we have to do here, which actually BabylonJS does too, is to create a WebGL render. But BabylonJS does this behind the scenes. But when you are doing this with Three.js, you have to add that line to have a render. And then we set the size of the render to the window's inner width and inner height. The reason we are setting to inner width and inner height is that because the canvas is the window is that size, window's inner width and height. You can have a canvas with different size, of course. And then we are attaching, appending the DOM element, which is the render. Render is DOM element, which is the canvas actually. And now this part is where we create the cube, where in Babylon there's the helper function that is one line that you mesh builder create box. Here we create a geometry, which means that this is defining the shape of the box. And the 111 is defining the width and height and the depth. So three aspects of the cube. And the second thing that we do is creating the mesh. This is creating a default basic material, and it's giving it a color. And this is a very fluorescent green. You can see the result here. And to create a mesh, you have to put those two things together with geometry and material and create the mesh. So together they make the cube. If you don't have the material, you have no way of showing how the light reflects off of the object. If you don't have the geometry, you don't have the definition of the shape. How does it look? We don't know. Those two things together create the mesh. And after that, you add that cube to your scene object. And in this case, we are moving the camera position, Z position, to 5, so it's not in the center. By default, anything that you create will be in the center. So in this case, we did create the box before, so it will be in the very center. So we want to move away so we could see the cube. And finally, we have the animate function, which we didn't have to have for the Babylon. You can have any rotations or any other value changes to this animation. But what's happening here is that it's using the request animation frame and then giving it itself. So it runs 60 frames per second, or I think so, or 64. Anyways, so it runs over and over and then renders every every second renders a 60 frames together, so that will make a very smooth animation. And we give the render function the scene and the camera, so we know which scene to render and from which angle we need to render. One other cool thing that the request animation frame does is that it is very efficient. Whenever you are not on that tab, for example, if there's an animation and it's costly, it stops that animation. And when your machine is not able to render as many frames, it skips some of them and still try to render a very smooth animation. So we can open up the fiddle here and then uncomment these lines to see the animation. All right, if we click run, now it's running. We comment out one side. The rotation is limited to x-axis versus y-axis. Okay, anything that you have on JS Fiddle, you can save it or embed it anywhere. Same for Playground. So that's it for today. I'll let you know next time how we can create the same scene with A-Frame and ARJS. If you want to see these slides, you can go to, again, WebXR, bit.ly/WebXR curriculum. WXR and C is capitalized and it's case sensitive. Bye-bye.